One of the Fortissimo case studies was a cloud-based optimization of a wave energy device. The partner in this experiment was Zyba. Zyba is a UK-registered SME with expertise in digital and numerical modelling. Since 2014, Zyba's primary goal is to engineer beautifully simple systems that work with nature. Zyba's core product, CCell, is a curved wave energy converter. Zyba's CCell technology harnesses wave energy and uses the generated electricity to power an underwater electrolysis process that results in the accretion of limestone rock around a steel structure. This forms artificial reefs from seawater minerals, providing a habitat for corals to grow at an accelerated rate. These dynamic breakwaters protect coastlines where natural reefs have disappeared.
The CCell system needs to be optimized for each site, so this includes taking into consideration the wave conditions and the local bathymetry. At Zyba, we do that optimization using numerical models, but unfortunately these are quite computationally intensive. That is typically beyond the reach of most SMEs, and particularly ourselves. Physical testing is possible as an alternative, but it is also expensive and has several limitations.
Simulations of the CCell device were carried out on an HPC cluster to interrogate the design space and system interdependencies using OpenFOAM. An easy-to-use graphical user interface was developed to accelerate simulation setup with a series of scripts and tools written to streamline the workflow on the HPC system.
The CCell device comprises of a number of different systems: the prime mover, the power takeoff system, and the control system, all of which impact the loading on the structure and the energy conversion. We needed a workflow that could encompass all of this and provide the design team with key insights into the system interdependencies. Our CFD simulations now incorporate a realistic representation of the hydraulics and are also coupled with an open source finite element modelling package. This has greatly sped up the optimization of CCell and helped get our pilot deployment in the water.
The use of HPC resources reduced simulation setup time from 2 hours to less than 1 minute. By mitigating the need for extensive physical modelling, design costs were reduced 9-fold. As all the software used in this experiment was open source, the HPC costs were reduced from €0.09 to €0.05 per core hour. The ability to concurrently run parallelized simulations improved productivity by a factor of 7.
The provision of resources from an HPC center transforms an imposing capital expense into a much more manageable operating cost. Using HPC centers, we've been able to effectively outsource administrative tasks associated with IT management and upgrades. This alleviates a lot of pressure from small SME teams with limited resources and reduces design interruptions as well.
As a result of the experiment, productivity has increased dramatically. A more automated and streamlined design process enables Zyba to rapidly optimize designs, which reduces costs and development time. With the new GUI, less experienced users can now also complete design tasks, increasing team efficiency. This has enabled Zyba to significantly speed up its market entry by 9 to 12 months, and it will also facilitate the evolution of future products and service offerings.